All right. First of all, as I'm looking at units here, the metric system in this case, this is at Wikipedia in the sciences and math. That's what I teach, physics, astronomy, math. I totally trust Wikipedia as soon as someone tries to take out a fact, because that's what sciences and math are based on. It's very quickly fixed. So here's International System of Units. We use also a different word for it, metric system. There we go. And it starts focusing on the 7 base units that we have, meters, second, kilograms, and then we get into thermodynamics, which is the mole and the Kelvin, and then we get into electricity, which is the ampere, and then into optics, which is light intensity, which is the candela. Sounds like candle, right? So I'm going to scroll a little bit down. Anything else besides these base units, combinations of them are called derived units, and here are the base units again, by the way. And here are the derived units, and of course there are lots, and you would have the same in the American system. So for example here, force weight, which is the Newton. Notice that this is combined here, kilograms meters per second squared. I didn't mean to scroll here. And in the American system, well, that would be the pound, and it also would be a combination of slugs times feet per second squared, that kind of thing. Or if we find somewhere here, acceleration should be somewhere on here, except I don't see it right now, or velocity, we would have meters per second versus feet per second, that kind of thing. So these are derived units and the base units in the metric system or the International System of Units. All right, a little bit more here. These are the prefixes that you might be familiar with. So here's the kilo, for example, which means 1,000. We don't really use the mega a lot. We just call it 1,000 kilometers kind of thing. We would never call it megameters. And then there is the centi here, or the milli, which we use for centimeters and millimeters. Just makes it easier to work with numbers that are nicer if we reduce the unit to centimeters or millimeters or centiliters, that kind of thing. This is actually from my first physics lecture that I give in my physics class. So how did the base units originate? I highlighted these 7 over here. I'm just going to go over the first 3 here. So the meter originates from going from the equator to the pole, apparently through Paris, and dividing that by 10 million, that's where you get the meter, or divide by 10,000, that's where you get the kilometer. Looks a little cumbersome because you're really not going to walk that way, but you can use that anywhere on Earth, that particular measurement. The foot, on the other hand, well, yeah, it's nice, there's a foot, but everyone has a different foot. So that one is one measurement that can be used all over the world, and yes, you're not really going to do it. It's actually an astronomical measurement, or surveyors would be figuring that out using actually astronomy for that, and that's how you get the meter. And then there is the prototype, which is, I believe, over here, where that would be exactly 1 meter long. And then you get the meter, so you divide that by 10 million. Now you get the meter. You divide the meter by 10, you get what's called a decimeter, respectively, that's 10 centimeters. You make it into a cube, which is 1 cubic decimeters, or 1,000 cubic centimeters. And we give it a new name, we call it a liter. We fill it full of water, and that amount of water that we have in there, exactly 1.0000 liters of water, is defined as 1.0000 kilograms. That's how the kilogram is defined, through the meter with the density of water. And that's also why it's not surprising to find in the metric system that the density of water is exactly 1.0000 grams per cubic centimeters, or 1,000 exactly kilograms per cubic meter. So that's the history for both the meters and the kilograms. The second, well, take the length of a day, divide it into 24 hours, divide it into 60 minutes, divide it into 60 seconds, respectively. Just divide the whole thing by 86,400. There's the second. And notice that this one really starts out not kind of nicely with decimals or metric, but at the end we still get the 1 second based on a measurement that anyone can take in the world. Let's see, this one is a follow-up about the other units in a metric system, but I'm just going to go on here to the imperial system or American system. So F for the foot, just like it sounds. There it is. That's, for example, here. Take these people out of church, 16 randomly chosen, and you get the rod, I guess, and if you divide by 16, hey, you get the foot, an average foot, right? The seconds is the same. Divide by 24, 60, and 60, or divide by 86,400, and you get the seconds. In a pound, you would actually have to, I got this here from the Wikipedia, and it's actually a little bit confusing. There's really, historians cannot really say, where did we get the pound from? But anyway, it's out there. By the way, when you abbreviate it for the plural, it's still LB, not LBS, it's actually LB in the plural, because it comes from the Spanish libre, which already is pounds in the plural. All right. So here's what I call quickly the American system. Its real name is the United States Customary System. A little bit of a long word. I think that might have been the first that I used. I really try to avoid that when I record. And we can see that it's only really used in the United States, Liberia and Myanmar. Everywhere else you have the metric system. And I guess Canada and Great Britain are a little bit of a mix between those. All right, so remember that for the metric system, it's pretty much start with the base units and then get to the derived units. You have these in the American system as well. For example, here's the inch. Then there's another, I should stop doing this. And then somewhere you find here the pound or the slug actually. But you also have a lot of these derived, not even derived units, but units that are related to them, but they have these really strange conversion units, such as 5,280 feet in a mile, or 1,760 yard in a mile, or 3 feet in the yard, or 12 inches in the foot. And that just goes on for all these kinds of units. Here are areas. Look at all these screen numbers in the metric system. You just multiply by 1,000, multiply by 1,000,000, divide by 1,000,000, that kind of thing. So here in this particular one, they're not focusing on all these units. They're focusing on how to convert between the different kind of volumes that are there. And that, of course, makes it quite a bit harder in the what I call the American system. By the way, there are actually exactly 231 cubic inches in the gallon. I learned that not too long ago. All right, that's basically it, what I want to say here. I just mentioned the number 231 cubic inches in a gallon exactly. This is in the pound, and this is an announcement that I post on March 14th, which is Pi Day 3.14 and so on, March 14th. So in the spring semester, and I posted in the summer semester as well on July 22nd. 22/7 is an approximation of pi. Notice here is the approximation 3.14285, and here's 3.14159. That would be actually the more exact pi. Now, hundreds, thousands of years ago, people didn't use the exact number for pi. They used an approximation, which is 22/7, because they didn't have calculators. So here is the connection to the gallon in just a moment. Pi, of course, is the diameter of a circle compared to its circumference. So divide the circumference by the diameter, and you come up with pi, 3.1415, and so on. Respectively, the approximation for it is 22/7, and in calculations, that might just work easier, and it has been used for a long, long time. So if you read through this one here, then the original gallon from 300 years ago, you can read about that in this Wikipedia page, The History of the Gallon, is based on a cylinder that's 7 inches in diameter and 6 inches tall. And using that with the actual pi, 3.14159, you come up with 230.8 cubic inches. Except they didn't do it that way. What they used is, for pi, was the approximation 22/7. So it's a little bit off, 0.04% off, as it says here. And did that, and came up with exactly 231 cubic inches, and that is the definition for the gallon. And I think that's kind of cool. You use a number that is slightly off from the actual pi, and that is how this particular unit for the gallon is defined.